Hi Year 12, today what we're doing is we're using the chain rule and we're going to establish and use the formula of the integral of f dash x of fx to the power of n dx is equal to 1 over n plus 1 of fx to the power of n plus 1 plus c, and this is where n cannot equal negative 1 and it's the reverse chain rule. So the chain rule for ax plus b to the power of n is the integral of ax plus b to the power of n dx is equal to ax plus b all to the power of n plus 1 over a lots of n plus 1 plus c. This is where our n cannot equal 1. We then have our chain rule for f dash x of times fx to the power of n, which is the integral of f dash x times fx to the power of n dx equals 1 over n plus 1 of fx n plus 1 plus c. Now this here is on your reference sheet for you, so you don't need to remember this one. The one above you do need to remember though. Okay, so let's look at how we use these formulas to find the integral of certain things. So what we have for a is we have the integral of 2 to 3 of 3 minus x to the power of 8. And so we're going to use this pink formula here using our reverse chain rule. What we have is we have it written a little bit differently, okay, but we'll be fine with this. So we need our dx here. I can't believe I forgot that off. We are going to use this formula. So we have our integral of ax plus b to the power of n dx is equal to our bracket of 3 minus x to the power of our 8, which is our n. We're adding 1 to that. This is all going to be divided by the derivative of the bracket is what that a is standing for. So the derivative of the bracket is minus 1 times our n plus 1, so plus times our 8 plus 1, and we have our values to substitute in of 2 to 3. So then we can simplify this, so we'll have 3 minus x to the power of 8 over minus 1 times 8 plus 1 is negative 9, and we will substitute in our values of 2 and 3 for this now. So what we'll have is we'll have 3 minus 3 to the power of 9 all over negative 9 minus, remember, we put a bracket around our second thing that we're multiplying in, 3 minus 2 to the power of 9 all over negative 9. So when we put this in, we get 3 minus 3 is just 0, to the power of 9 is still 0, divided by minus 9 is still 0, minus we'll have our 3 minus 2 is 1 to the power of 9 is just 1 over negative 9. So this is just going to be 0 plus a ninth, which equals 1 over 9. Alrighty, our next example, we have the integral of 1 over 2t minus 3 squared with respect to t. What we need to do is write this as everything in the numerator. So this means we're going to have a negative indice. It is going to equal the integral of 2t minus 3 to the power of negative 2 with respect to t. And then we want to integrate this. So when we integrate this, we write our bracket on the top, so 2t minus 3. We drop our we add 1 to our power, and then our derivative of our bracket, which is 2, times our power of minus 2 plus 1. And because we don't have our a and our b, it's not defined, we have to remember to add our c on the end because we don't have any values we're substituting in. So then what this looks like is we will have 2t minus 3 to the power of negative 1 all over 2 times minus 2 plus 1 is minus 1 plus our c. So what this is equal to is 2t minus 3 to the power of negative 1 plus c all over negative 2. And then we can rewrite this without our negative power. So it will be 1, and we can bring that negative up the top too. So negative 1 over 2 lots of 2t minus 3 to the power of positive 1 plus c. Okay, example 4. We have the integral of 0 to 4 of 4 over the square root of 2x plus 1 dx. So again, what we need to do is we need to rewrite this without our surd being in the bottom. So this is equal to the integral of 0 to 4 of 4 bracket 2x plus 1 to the power of negative a half dx. Okay, so now we need to differentiate this. So we write our numerator up the top. So we write our 4 bracket 2x plus 1. Okay, so we just write that up top, and then we are adding 1 to our power all over. Our derivative of the bracket is 2 times our negative 1 plus 1. And we have our values of 4 and 0 to substitute in there. What this is then equal to is 4 lots of 2x plus 1, negative a half plus 1 is positive a half, all over 2 times negative a half plus 1 is equal to 2 times a half. Then this is 4 times the square root of 2x plus 1. Oops, I forgot to write what I'm going to be ending up substituting in, which is my 4 and my 0. So this is 4 times root 2x plus 1 all over 2 times a half is just 1, so I'm not going to write that there. Say that I'm substituting my 4 and my 0, and now I'm going to show that I'm substituting them in. So what I can also do is I can bring this 4 out the front, because it is not going to get impacted by when I substitute anything in. So I have my 4 out the front, root 2 lots of 4 plus 1 minus, in brackets, root 2 lots of 0 plus 1. And so then I'll have 4 lots of root 9 minus root 1, which is equal to 4 lots of 3 minus 1, and 3 minus 1 is 2. So it's equal to 4 lots of 2, which is equal to 8. Okay.